Great. Welcome, everyone. What a great introduction, and so glad you could be here. I'm Adam Stern, Executive Director of Acterra. We are a regional environmental organization with programs focused on energy and climate, corporate sustainability, and land stewardship. This is the third of our lecture series this spring, and we're delighted to have you here. We do these to provide a forum to stimulate discussion about leading environmental issues of our time. First of all, I want to thank our hosts, Facebook, and our series underwriters, Mary and Clinton Gilliland and Armand and Eliane Newkermans. Thanks. And we also have some supporting sponsors, Toby Cooper and Gary Bladen of Merrill Lynch in Menlo Park, Winter Williams of Community Bank of the Bay Area's Green Fund, Chris Robbins of the Clean Fund, and tonight's featured sponsor, Lauren Agnew of Seal Cove Financial and the Bay Area Impact Investing Initiative. So thank you. You know, the modern environmental movement owes its success in part to the photos of Earth from space that Apollo missions produced in the late 1960s. The image of a fragile planet, a blue marble set against a black universe, inspired millions of people to demand laws to protect our air, water, and protect natural lands. And that image is all the more important today as we confront challenges like global climate change. I'm pleased to present to you someone who has actually seen the Earth from space, and after 4 space shuttle trips and 7 spacewalks is using what he learned to help make life on Earth more sustainable. Please welcome our speaker this evening, Astronaut Steve Smith, Associate Director for the International Space Station at NASA Ames Research Center in Mountain View.
Good evening. It's fantastic to be here. Usually I don't use notes to speak, but I'm going to tonight just for a couple things because this is an incredibly special audience. I've done 800 or 900 public speeches, and rarely do I get such a appreciative audience with so many varied interests that I'm also interested in. So I'm going to try and concentrate on that. But I want to thank Acterra. Adam, thank you so much for arranging for this, and your underwriters, and also your sponsors, and also to Facebook for sponsoring us here tonight. But I want to thank all of you in particular for being here tonight. We all have very busy lives. You obviously have an interest in the environment and hopefully an interest in the space program too that brought you here tonight. So I'm really grateful for that. And I'm going to work really hard to use your time very wisely. And that's why I have notes, and I usually don't. I also want to acknowledge Peggy Brannigan, my wife. People, don't take too much of my time. I don't have much. We are on a tight schedule. You know, people think the astronauts are, brave, and we do all these special things. Really, the heroes are the spouses and the mommy and daddies and siblings who are watching us blast off on a rocket ship into space. So thank you so much for 4 opportunities to fly. I'm here tonight, just a reminder, I'm here tonight because I still work for NASA. So that means I'm a federal employee. I work for the US government. And for those of you who are US taxpayers in the room, I'm your servant. I actually work for you. I hope you can hear the tone of my voice that I'm actually here to try and educate you on what we do as your servant, really. So I'm really sensitive to your time, and I'm going to try and be as informative as I can. Probably you can already tell I'm a little bit informal sometimes when I speak like this. So feel free to ask me questions. However, since we're on such a tight time schedule, it might be helpful if you can hold your questions to the end or even afterwards. I don't have anything that I have to rush off to tonight. As long as Facebook and Peggy will let me stay here, I can answer questions out there. Now, if you have a question that you think will benefit the whole audience and you just can't wait, just give me the signal. Hey, I got to ask the question now, and I'll respond to it. But we have a huge challenge, When I was asked to do this, I thought this is going to be awesome. This is my type of audience. I'm going to make a special effort. There's so much I could tell you, and so I started off with a slide set of 70 slides, and I've worked it down to 30. It was painful to delete every one of those 40, but we do so many things at NASA, so many things. And so the main theme tonight will be the Earth, obviously, and also the human spaceflight part, because that's the part of NASA that I'm from. I almost guarantee that you'll learn 30 new things tonight. There won't be a test at the end, but I'm going to be throwing things out there that I guarantee you've never heard before. And I think it's more than 30, but I'll just stay at 30. God bless you. We are being filmed, so I'm not going to be quite, I don't know how they're doing that, but they're filming us. But I'm going to be maybe a little more formal than I usually am. Let me ask you a couple questions just to start with, just to kind of give me some sense of the audience here. How many of you have seen the movie The Martian? Just quick hands, great. Wow. How many of you have seen the movie Gravity? Okay. How many of you have seen the movie Interstellar? Okay. Wow. How many of you have seen the movie Apollo 13? Great. There's one smaller movie that I would suggest you watch if you're a space fan. It's called October Sky. How many people have seen October Sky? It's a true story about Homer Hickam, a young boy who, when he was a young boy, he grew up in North Carolina, or no, Virginia, excuse me, son of a coal miner and became a NASA engineer. So October Sky is a good movie to see. How many of you fly airplanes or have flown an airplane before? Okay, great, thank you. How many of you work at NASA or around NASA? I know, I've heard there's 4 or 5 of you here tonight, okay, including my current bosses here, by the way. Well, both of my current bosses, both at home and at work. How many of you have served in the military? Well, look at that. Thank you so much for your service to our country. We appreciate it. And finally, I want you to really think through this question before you just raise your hand. If I could arrange for you to fly, let's say on the Space Shuttle, a week from now, for a 2-week flight, knowing what you know, how many of you would do it? Okay. Okay. All right. So let's move on. So again, kids. So I'm going to keep us moving because there's just so much I want to tell you. And again, you know, slide set went way down. So let's go to the first slide. Oh, I guess I control that, don't I? Sorry. And so, you know, there's 20 different chapters of NASA Story I can tell you. Sure. Pedro, can we bring the lights down, I guess, a little bit, they'd like? Thank you to Pedro, David, and Brandon in the back control room for their help. So the first thing I'd like to tell you is just where are we at NASA in human spaceflight? Again, there's NASA's many different chapters. This is the human spaceflight chapter. This is the International Space Station. It's up at about 240 miles right now. There's generally 6 people living on it. It took about 5 different space agencies to build it. There's about 15 countries involved because one of the space agencies is a collection of the European countries. There's kind of, did I end up getting a point or two? That's what this is. Can I get a point or two? There's kind of the Russian half, which is this part here, and then the other half is the USOS part. That's the United States and their partners, Japan, Canada, and the Europeans. The big gold things are solar arrays. And right now we have no shuttle going to the space station anymore. We did for many years, but in 2011 the Space Shuttle stopped flying. So the Russians have both cargo ships and spaceships that carry people. That's the way Americans get to space right now, which we want to change, and I'll talk about that. But we have arranged for 2 commercial companies to carry cargo to the space station. So you've heard of SpaceX, and then the other one's Orbital Space Corporation, and they both have spaceships up there right now. But the whole goal is to get out of low Earth orbit. We've been doing low Earth orbit work for 40 years. It's been a long time since we've been beyond low Earth orbit. So we want to change that. So where are we going? In human spaceflight, we want to go to Mars. Mars is on the right, the Earth is on the left. There's a lot of things on this page. But basically what it says is to go from the Earth, where we are now, to Mars is going to take about 20 years, but there's various steps. So here you see the International Space Station. We're doing a lot of technology demonstrations, learning how people live in space. Scott Kelly just came back from a year in space, but there's other steps here. So here's a new spaceship that I'll tell you about, new rocket systems. There's rovers on the planet already. There's 2 rovers currently from the United States on Mars that are working very well, but no one, of course, has been there yet. So this is what we're doing next. It's called the Space Launch System on the left. It's a gigantic rocket. It's much bigger even than the Apollo rocket. It will carry both cargo and people into space and hopefully into deep space, so to Mars, for example. On the right is the Orion capsule. There's a couple of people here who have Orion work going on. So it will carry astronauts not to the space station, but to deep space. So that's what, as American taxpayers, that's what's happening with your program now. Let's talk a little bit about economics. Again, very high level, very quickly. NASA's budget is about $19 billion per year. The federal budget is about $4,000 billion per year, or $4 trillion. If you do the math, it's less than half of 1% that NASA gets. And let me just go a couple slides forward. Okay. Actually, let me go back one. So just to give you some sense of how $19 billion shapes up against other government entities, this is the defense budget up until about 2014. You can see that they're about $600 billion per year. I'm not here to talk about whether that's the right amount or not. Just to give you some sense, though, if you're in favor, or if I meet someone who's in favor of saying, you know, I don't want NASA to exist, I want to give the money to someone else, if we gave it to the Department of Defense, they'd use it up by January 11th of a certain year. So that gives you some sense of how small our budget is. When you look at the other agencies that we kind of compete against, you can see we're sixth from the bottom here. This is, I think, a couple of years ago, 3 years ago. You can see we're at $18 billion then, but you can see the other obligations that our family, called the United States, has, and how much they each get. If we were to, sometimes people ask me, why are we going to Mars when I have homeless people? Or why are we going to Mars when our education system's suffering? The answer is, in any entity like your own family, you want to have a balance, a diversity among the money you spend. Of course, you spend most of your money on your current obligations, like housing, food, and clothing, but any smart family is also putting money away for the future. So that's what NASA is. In the United States government's budget, it's a small investment in the future. And so going back here again, I've told you it's a small share. The next bullet says it's a large ROI, a large return on investment. Studies that have been done over the last 20 or 30 years show that for every dollar that's invested in the United States space program, the return is 4 to 9 times that. Not 4% to 9%, 400 to 900%, both in jobs and new companies and things like that, new products that the commercial sector picks up. So it's a huge return on investment. So the conclusion that I propose to you on the fifth line is that your tax dollars that go to space for your space program are a small investment with a gigantic return. There is a publication that's put out. It's called Spinoff. I have it here today. It comes out every year, and it documents the products that come out that help our lives on Earth because we were trying to do something in space. So when we try and explore in space, we get 2 types of products. One are the products that we get because it's part of what we're doing. Like we go to Mars and we'll discover something special there that will help our lives on Earth. Just like all previous explorers found things that they didn't know would help their lives, and they eventually did. But also along the way, to get to that point, you find other things that benefit people's lives that aren't part of the space program. Those are called spin-offs. And so these are the things that come from the space program. And people always ask me, well, give me some examples of what some of these spin-offs are. And there's been about 10,000, and it's a little bit dangerous to just pick 1 or 2. There is a website, spinoff.nasa.gov, that I went to earlier this week just to kind of see what are the top 40. And they're pretty compelling. A lot of them are really compelling, and I invite you to go to that website. But let me tell you a couple or 3 examples of spin-offs. The first one is that at the International Space Station, we need water. And water is extremely heavy, extremely heavy. So to get water to the people on the space station, or to get enough water for people to go to Mars, is going to be very difficult because it's so heavy and the rockets have to be gigantic. So NASA said 20 years ago, we need to recycle as much of the water as we can. I can see some people shaking their heads. And that includes recycling urine, for example. So in your mind, what % of the water that we ship to the space station is recycled? It's 70%. 70. So right away, we should think, well, there's got to be some applications on Earth, especially in places like California for that, like that. So here we are helping us get to Mars, get into the exploration realm, but clearly that technology has spin-offs. And in fact, at the recent, I think it was called the Silicon Valley Water Awards or something like that, there was a company that was actually one of the recipients, I have their name here, that uses NASA technology to have systems that recycle water? Z-nano, thank you. That's right here. So that's what a spin-off is. Another one is where we use space to actually produce a product that benefits our life on Earth. And I'll give you this example. In electronics, silicon is used, right? That's why we call it Silicon Valley. Silicon carbide is a version of silicon that's also used to make computers. When we grow those crystals on Earth, when we grow those wafers on Earth, because of gravity, the crystals aren't perfect. So there's defects in them. So when you cut the wafers up and you make computers, the computers don't work as fast as they could, and they use more power than they should because those crystals just aren't perfect. As the electrons are trying to get through the lattice structure, it's a little bit of a blockage. There's a company called Acme, if you Google it, and they buy silicon carbide wafers that are made on Earth. They send them into microgravity, into space, and while they're up there, they heat them up. The molecules rearrange themselves. They turn the heater off. They bring the wafers back down to Earth, and they're perfect. And that's because in zero gravity, the molecules can all get organized, all right, we're all set up, and there's no defects. And so the computers then that use those are faster, use less power, et cetera. So it's this magic of microgravity that makes things like that happen. Okay, let's see. So my story, I always wanted to be an astronaut. These are some of the probably 50 drawings that my parents saved, God bless them. They're from the Depression era, so they save everything like, free shower caps from the hotels and, used applesauce containers. But they saved all my artwork, and I'm thankful for that. But, it doesn't just happen. And Peggy, if you were to ask her if I'm a minimalist or a hoarder, she would say, the guy's a minimalist. He doesn't save anything. Well, I did save 4 of these. So these are the wonderful rejection letters that NASA sent me every 2 years over an 8-year period that said, sorry, you're not in. But on the 5th time, they selected me. And once you're in that club, some really amazing things happen. I had 3 very influential people growing up. One was Jacques Cousteau, because I watched the undersea world of Jacques Cousteau, adventurism, contributing to society, going new places like this undersea world. Charles Lindbergh, who was deceased at the time, but his exploration using an airplane flying across the Pacific or the Atlantic. So, and the third was Lloyd Bridges, who was in the series Sea Hunt, which was kind of a fake Jacques Cousteau. Anyway, when I became an astronaut, I wrote Marvin Lambourne, my calculus teacher in high school, and said, thank you so much. 20 years later, here I am, an astronaut. Well, I wrote those 3 people or their families, these celebrities, and they wrote me back. So Jacques Cousteau and I ended up actually becoming very good friends. And then, when you're an astronaut, you can take your parents to dinner with Neil Armstrong, which is the upper right-hand corner. It's, boy, what a way to thank your parents, right? So that's a picture from Denver about 20 years ago. We talked a little bit about Peggy. So it's really a strange life when you're an astronaut. You go into quarantine before flight so that you're separate from the public, and so you don't pick up any colds, things like that. You remember in Apollo 13 when one of the astronauts got exposed to chickenpox, I think it was. So they put us into a quarantine. We call it jail because we can't go to the mall, we can't go to the movies, we can't see our kids. You can't see your spouse if he or she is healthy. So they have a medical screening, and if they're okay, they can come in and see you in jail. One of the things that we could do is take them out to the launch pad the day before launch. And so I flew 4 times. On the left is the first flight. This is the day before my first flight. And on the right is the flight 7.5 years later, the 4th flight. And when I look at this picture, I see maturity and more relaxation over the 7.5 years. I don't know if it's just because the photographic quality is better or not. But in little question there, I said, does the spouse want to do that or not? And as you can imagine, the response is there's a wide spectrum of responses. If you ask Peggy, she said, I loved it. It made me feel like part of the program. It got my mind off things. I felt special, because when we take the spouses out there, all the employees are, just treating them like royalty. But then there are the other spouses that say, I don't want to go anywhere near that death machine the day before. I'm just terrified. I don't want to do that. We did lose 2 of 102 flights on the Space Shuttle. That's 14 people we lost. All was preventable. So you can understand why some of the spouses feel like that. Going into space is awesome. I mean, it's absolutely incredible. Again, I told you I'd tell you 30 things you've never heard before. There's probably been 5 or 10 already. One is that we launched from Florida because there are physics reasons to do that. And I'll just give you a quick demo here. The Space Shuttle weighed 4.5 million pounds on the launch pad. And we wanted to overcome gravity. And if we put our launch pad at the North Pole, and we have 4.5 million pounds, during 24 hours, it's not doing anything except spinning in place, right? So if I was on the launch pad at the North Pole, in 24 hours, I would do that. If you put your launch pad as close to the equator as possible, what happens in 24 hours? So you can see the rocket is already moving on the launch pad. And so if you have 4.5 million pounds to launch, you want it to be moving in the direction you're going to launch. And of course, we launch that way. Wouldn't make any sense to go the other way. So any country that's launching rockets always likes to launch from as close to the equator as possible. New fact you just learned, right? And that's because the dirt there is moving a lot faster than like in Maine or New York. So that's why we launch from Florida. We also want, since we're launching to the east, we want to launch over the water. So that's a good place in Florida. The Europeans, which are up here at 52 degrees latitude, that's not very efficient for them to launch from there. So they have a little piece of land in French Guiana, which is at the equator. So the Europeans ship their rockets on a boat to South America and launch from there. When we go from the launch pad to space in 8.5 minutes, we go from the launch pad, and when we're on the launch pad, we're going 1,000 miles an hour already. So this building, all of you, since we're not right on the equator, we're at 30 degrees north latitude, we're probably going 700 or 800 miles an hour right now, relative to the center of the Earth. And it doesn't look like that because we're all together. But we are going really fast right now. So it's another fact you can remember. But we go from the launch pad to Mach 25, so that's 17,500 miles an hour in 8.5 minutes. So it's a ride, it's an incredible ride. It's the best part of the job. That means that we're traveling at 5 miles per second. I mean, I can't even comprehend that. To this day, I still can't comprehend that. Can you imagine if I could get the Space Shuttle Endeavour for a day, bring it up from Los Angeles, gas it up, and drive by here on 101, and we all stood at the side of 101, and I told you, okay, here it comes. I would actually say, did you see it? And it went by, because you wouldn't be able to see it, because Mach 25 is approximately 8 times the speed of a bullet. So you'd probably hear it, you'd go, I heard some wind or something. But Endeavour weighs 200,000 pounds, and it's the size of about a Boeing 737. But if it's going 5 miles per second, which it can't do in the atmosphere down here because of the heat, but it just, I didn't even see it. So it's really this incredible life. The shuttle weighs 4.5 million pounds on the launch pad. Usually we could carry about 20 to 30,000 pounds of cargo with us. So that's not very much. That's how hard it is to overcome gravity. So that means that only 5% of that stack returns to Earth. So when the shuttle comes back, it doesn't have the external tank or the solid rocket boosters. And that means that the payload was 0.6% of the total weight. So gravity is tough. Gravity is tough. We're having a great time in here at the cockpit at this point. We're not scared at all. We don't think anything's going to happen to us. It's going to happen to somebody else if anything happens. I mean, it's terrible to say. It's a defensive mechanism. Now, who's terrified at this point, potentially? Peggy, Lily, and Bob, my parents. I mean, please don't blow up. Please don't blow up. Because we did lose 2 out of 100. Okay, so that's 1 out of 50 chance of not coming home. So if you raised your hand at the beginning, it'd be interesting to know, did you think about that? We go up the elevator to get into the space shuttle. You can see the hatch over my left shoulder there. We've got the orange suits on. They're orange because if you jump out of the shuttle on launch and you end up in the ocean, they want to be able to find you easily, so that's why it's a bright color. Parachute, oxygen, life raft, radio, things like that are in our backpack. Life is strange, though. You go through the door, you crawl into the space shuttle, and the chairs are on the wall. Because it's not like your airplane at the airport. You walk in, you go row 3, seat C, right? On the space shuttle, they've turned it onto its back, onto its butt, onto its tail. And so when you go in, the chairs are on the wall. So you can imagine if we had played a trick on you and put the chairs on the wall. It's this very strange life. Once you're in space, of course, zero gravity is very magical. There's Velcro everywhere because things float. That's what the blue stuff is on the walls. We use a lot of gray tape. We would take 15 rolls of gray tape with us because cables don't fall to the ground in space, right? So cables, they're floating everywhere. So you use gray tape. You'll notice the colors are floating up on my shirt. There's about 1,500 switches in the cockpit of the shuttle. Because we're traveling at Mach 25, 5 miles per second, we go around the world in 90 minutes. So in 24 hours, we go around the world 16 times. That means in one day, the sun rises 16 times, and the sun sets 16 times. So 45 minutes of light, 45 minutes of day. 45 minutes of light, the sun goes up and down and up and down. It's a really strange life, but that's why you often see us with the sunglasses on our forehead, even at night, because it doesn't make any sense to put them in your pocket, because you're gonna have to take them out 45 minutes later, and of course there's a bungee cord in the back. But you'll see Velcro on everything, every little piece of the camera, not just on the camera body, but if I take that lens off, I need to have Velcro on it. 2 watches. When you're traveling at Mach 25 and you're going around the world every 90 minutes, you lose track of what time it is at home. So the black watch, which I have on here, I always kept on time where Peggy and the kids were in Houston, Texas. The other watch is set to mission elapsed time. So you'll often see astronauts with 2 watches. This is a picture from the space station. You know, again, there's no gravity. You can do whatever you want. You can fly up on the ceiling. We brought a keyboard to Carl Waltz, who had been on the space station for 4 months. He loves Elvis Presley and is a very talented musician. But when he played the piano, he had to put a bungee cord around it and around the back of his legs, because otherwise, when he touched the keyboard, it would just fly away, right? So you have to think of things like that. Okay. So John Grunsfeld and I had finished doing a spacewalk on the Hubble Space Telescope on Christmas Eve, 1999. And someone said, hey, we got the Santa Claus hats with us. Let's take a picture, send it back to Earth. So we put the hats on. Didn't look too good because there's no gravity. And you can see the ball, instead of falling to the side, just floated straight up. No shower in space. So out on the table out there, I had some of the waterless shampoo we use. There's no shower because, of course, if you turn the shower on and you stand there, the water's not going to fall on your head. There's no gravity. The water's going everywhere, so you're trying to get it on your head. So that just doesn't work. That's one of the things the astronauts really miss, is taking a shower, that feeling of the water coming over your face. So that's one of the first things the astronauts want to do when they come home, is take a shower. In fact, Scott Kelly, who just came back from a year in space, what was the first thing he did when he got home? Jumped in the swimming pool. He just wanted to feel water again on his body. So you can see the waterless shampoo floating in front of me there. But again, how it works is you just put it on your skin. It clings to your skin. You take a towel and you rub it off. So there's no water involved. It's for people who are hospitalized for long durations on Earth. I got the 2 watches on. Sleeping. Sleeping's a little bit difficult and when you're new, because you're so excited to be there. I don't want to go to sleep, But also, you don't have that feeling you do on Earth of the pillow in a certain place, and I put a pillow between my knees, or I'm on my back. Whatever your way of sleeping is, you can't do it in space. And you don't have that feeling of the blanket, for example. So it's pretty hard to sleep, especially the first flight, and especially the first few nights. We can take melatonin, and we also have something called Ambien we can take. If you're doing a spacewalk, you're pretty exhausted from the spacewalk, so on a spacewalk day, it's not too hard to sleep. But anyway, when it's time to go to sleep, you can put your sleeping bag wherever you want. It has Velcro on it. This is the Space Shuttle middeck. Whenever I was in space, I always wanted to sleep on the wall or the ceiling, because you can't do that on Earth. So I thought John was making a mistake here, just sleeping on the floor. So I'm about to go to sleep on the wall. And a couple things when you're sleeping in space. So we're inside of a sleeping bag. And when you start to fall asleep, it's not perfectly tight. So you're actually kind of floating inside of the sleeping bag. It's like a cocoon, right? And so that, you're like, oh, this is really weird. It takes a little while to get used to. And the other thing is, you got to think about your arms. If you don't put them inside the sleeping bag, what are they going to do at night? They're going to float around. And it's really scary to wake up on the wall with your arms in front of you. So usually you put them in the sleeping bag. This is a fake picture. I haven't fallen asleep yet. The other thing floats around is your head. So you can see there's a seatbelt across my head. Otherwise, your head floats around all night. I can't sleep with my head floating around all night. And I want you to really try and absorb what it's like to be in space. I was, 35 the first time I flew. So for 35 years, when I woke up, that was the ceiling up there, there was the wall, and here's the floor. All of a sudden, I wake up one day, and I'm sleeping on the wall. And you wake up, and you're like, where's the bathroom? I mean, it's hard to imagine, but if your mind has been trained for 30, 40 years on how things are oriented, and all of a sudden you change them, and you can't practice this on Earth, right? Spacewalks are awesome. That was kind of my specialty. This is me with the Hubble Space Telescope in the background. You can see the Earth, beautiful picture. So Hubble's been grappled by this arm you see in the picture here. And I am tethered so that if I lose my grip, I can come back, pull myself back with the rope. If the rope breaks, they're going to throw this Hubble Space Telescope away forever and come and rescue you. So you really don't want to be famous by doing that. So you make sure this hand is on before you grab it this one, so you're very careful, in other words. And on the space station, we actually wore a jet backpack because it would be hard for the shuttle to come in and get you if you broke free. But just an awesome experience, awesome experience. The way we practice for spacewalks is in a giant pool. There's nowhere in the world where you can have no gravity to practice something. So in this giant 16 million gallon pool in Houston, you can see in the water, there's all kinds of mock-ups there of the space station, of the space shuttle, and of the Hubble Space Telescope. This is the Hubble Space Telescope right here. So that's how we practice. We put on fake spacesuits, and then we do at the time, about 10 hours of spacewalking practice in the water for every hour that we were going to do in space. And I can tell you the first time I went up to Hubble, of course, I'd never seen it before, right? Because it was in space when I became an astronaut, so I never had a chance to see it. It really felt like I had seen it before because I had spent hundreds of hours in the water climbing on a fake one. And there's also a fake one on land that's a little bit higher fidelity. But it's really great training. The spacesuit weighs about 300 pounds on the ground. So anytime you try it on the ground, they actually have you on a crane. So you're trying it and you go, oh, this fits pretty well. And they size it for you and everything. It has 7 layers of material. One of them is Kevlar, and that's to protect us from micrometeorites. We buy our own life insurance, if you can believe that. And if you're going outside, the premium is double because it's so dangerous to go outside. There's only one company in the world that offers the insurance. It's the NASA Employees Benefits Association. I don't know if NASA employees know that, but anyway, if you look carefully, you'll see it has lights on the helmet, and that's because we work in the dark half the time, right? You can see the Earth reflecting in my visor. If you look closely inside the helmet, there's 2 white pads, and that's because when you have the spacesuit on, you can't itch your nose because you can't open the mask and put your hand in there, right? You'll die instantly. And you can't, sneak your arm in, itch your nose. And so there's 2 white pads there that you just kind of, if your nose itches, and your nose always itches when they put the helmet on. So, and a lot of times it was a trick. When someone would put your helmet on to go outside, then they'd go like this. And so you'd say to yourself, if his nose itches, then mine must itch, right? A couple other things, there's a canteen with a special straw inside because again, you can't, take a drink of water for the 8 or 10 hours you got this thing on. There's a special straw, it's right by your mouth here. If you're gonna sneeze, you sneeze into your shirt because if you sneeze straight ahead, no gravity, the spit, it's gonna, you're gonna have to, you're kind of looking through there, it's gonna go in your nose and in your ear. And we wear a diaper. So if you raised your hand before that you wanted to go into space, now you have to decide if you're willing to wear a diaper. We wear them for launch and entry in the orange suit and also when we do spacewalks. There's mirrors on the hands because we cannot see the control panel because of the neck ring. So you'll see a mirror on each hand. That's how we read the dial, and then we use the other hand to change the volume of the radio or our temperature. And because we're using radio, all the words on the spacesuit are printed backwards. So if you were to look really closely, all the words on the front of the spacesuit are backwards. That's Hubble on the right. You can see I have a tether there to make sure I don't float away. One really huge issue with going to Mars, it's our greatest challenge right now, is how do we protect the astronauts from radiation? That is the single biggest issue. As you know, here on Earth, we're protected by the magnetic fields of the Earth. That's why the radiation here on the ground is not that bad. But when we go away from the Earth, we don't have that protection. What we have here, as I'm considered a nuclear worker because I went out into space, so NASA's obligated to report my radiation exposure. And the reason I show you this drawing is it has my 4 flights, okay? And then it has the altitude. I think it's in kilometers, yeah. So basically 120 miles, about 350 miles. And then this column shows the dose of radiation I got. It's not important what the units are, but look at the difference between the 1st and 4th flights and the 2nd and 3rd. That's because those were Hubble flights, and Hubble is much higher than the space station. So when we went to the Hubble, we were exposed to more radiation than the people on the space station, for example, by a huge factor. It might even be logarithmic. But it's pretty stark because then they give you your increased chances of cancer, basically. So what's the biggest problem with going to Mars? So now let's slow down. We have about 20 minutes. Good. We got to the Acterra part. Here we go. So listen carefully because I have some, I think, some very interesting things to tell you. So Earth is a beautiful blue and green marble in space, in this beautiful ocean. Excuse me, I forgot one of my props here. And this picture was not taken by an astronaut. It's too far away from the Earth to get a picture like that. We are much closer to the Earth. So it was taken from a satellite. But it gives you this beautiful sense of this gorgeous, gorgeous island. And when astronauts look at it from this perspective, it changes you. and it can change you in 2 or 3 ways. One is just basic spiritually. Basics, because you look and there's 7 or 8 billion people down there in that little orbit there. How did I end up lucky enough to be on that? A little bit to the right and a little bit to the left is nothing. I mean, we cannot survive in the black part of the screen. So you think about things like that. And in fact, the 12 gentlemen that walked on the moon for America in the 60s and 70s, a handful of them looked up, and they're digging for rocks. And they look up and they go, oh, there's the moon up there, And then they're like, I'm on the moon. That's the Earth. And you've read, I think it was Jim Swigert would say, I could block out all 4 billion people at the time just with my thumb. I could block the Earth out. It really affected them. And we shouldn't be judgmental. None of us have stood on the moon and know what that's like, right? So I really appreciate the fact that they really, it's really affected them. But in any case, I think for the modern astronaut, where we just fly around the Earth right now, we have not been out to the moon in a long time, since 1971. That's why I showed that first chart where we need to get back out there. It takes about 2 or 3 days to get to the moon, by the way, from this beautiful planet. It takes 9 months to get to Mars. So remember I talked about radiation. We're not talking about a 2 or 3 day trip, 225,000 miles to the moon. Mars is a long way out there. So it's 9 months there, and you want to stay there for a while. Then it's 9 months back. So it's going to be tough. Anyway, back to this beautiful blue and green jewel. The second thing is you don't see any borders. And there's been a couple songs over the years, From a Distance. Carla Bonoff sang it. I think Linda Ronstadt sang it. And it talks about how when you look at that, you cannot imagine that there are people fighting down there. And that is the absolute truth. It's the absolute truth. I mean, when I was looking up there, I'm thinking, man, that is one global community. And so, a lot of our marketing materials for different companies talk about, we're a global enterprise and we're part of the global community. We actually are. That's not an exaggeration. We are a member of this village, this beautiful island. And, when I speak to young kids, I say, let's imagine you're on an island. Let me pick 6 of you, and I'm going to put you on an island. What do you have to worry about when you're on an island? Well, you should get along with each other, right? So peace on earth, be tolerant, things like that. The second is take care of your environment, right? Which is what Acterra is about, and I'll talk a lot about that coming up here. So I want you to imagine that we take a break right now, and we walk out of this room, and you're out there mingling, and we covered the floor in here with beautiful black velvet, just the blackest velvet we could find. And I take this little blue and green marble of Earth, and I stand over here on this wall, right here, and I just stand against this wall, and you all come back in, and you come back in, and you just line the walls. Everybody stand on the wall. So think about what this room is. It's this big ocean. And I just let the marble go, and it rolls, and it rolls, and it rolls, and it just stops somewhere. So imagine that blue and green marble on this vast black ocean, which we're simulating with velvet. Or maybe we go to Levi Stadium and use a big stadium, whatever. It's this beautiful blue and green marble, this little island in this big black ocean. And I'm preaching to the choir. A lot of times I'm trying to convince people to think of it that way, but that's what it is. That's really what it is. And it really affects how I approach things when I came back. One of the things that I was being interviewed by Miles O'Brien of CNN at the time while I was in flight. He goes, Steve, what's it like being in space? Well, I said, it's such a beautiful sight and it makes me more tolerant. And so, for example, on a practical basis, when someone cuts me off on I-45 in Houston now, I'm more tolerant. That's a brother of mine or that's a sister of mine. We're one global community. I'm going to be tolerant of that. And Miles O'Brien says, that's Astronaut Steve Smith's solution for road rage right there. So anyway, you have never been to a presentation before, most of you, where the presenter worked very hard to get a picture of you into their public presentation. So you are in this public presentation because this little ball in the beautiful ocean is in that picture. It's a little dot. And this is what one of the Mars rovers took a picture of in January of 2014. So unless you were on some other planet, you're in this picture. And you have got to get over any skepticism with some of the things I'm saying because you are in that picture. You are in that picture. That's not a joke. Oh boy, look at what we're doing to this beautiful blue planet. This is from the website referenced up there. That's a steep line, very steep. I've heard that it levels out, this is the world population total, curve. I've heard it levels out at 10 or 11 billion. I'm not quite sure I believe that or understand why, but in any case, it's pretty steep, and there's a lot of people on this beautiful planet, so it's really motivation to take care of it. And if you look at the small writing up there from this website, ecology.com, the population is growing a person every 2 seconds. 2 people, 2 people, 2 people. Pretty amazing. Our island is spectacular, and we all live in a beautiful place, so we know this, but you know, when we see it from satellites and from taking our pictures, it's beautiful. This is, of course, a volcano with water in the crater. This is in South America, the Uppsala Glacier. You can see the beautiful glacier moraine there. You can see some of the fragments breaking off of the ground, the beautiful color of the water there. This is in Australia. It's a salt lake in the middle of Australia, so you see these beautiful patterns from space. This is Namibia, where you've got these gigantic, you know, several 100-foot high sand dunes that come right up to the ocean. Just absolutely beautiful. We see volcanoes erupting. This is Kamchatka Peninsula. A volcano erupted on my first flight on my first day. Can you believe that? You know, one of the things I haven't told you is that a lot of us get sick in space. I'll come back to that. But so I'm not feeling too good, and someone says, Steve, you got to get up here. There's a volcano erupting. So it's pretty cool. I'll digress just one moment because a lot of astronauts get sick when they go into space, about 60 to 70%. It's because of the lack of gravity. It does funny things with your inner ear, just like seasickness. Most of us get over it in a day or two. Some don't. We use something called phenogrin sometimes to treat it. But the reason I mention it is, again, I've tried to tell you how strange my job is. I actually have a job where I know when I go to work next Tuesday, I'm going to throw up. So it's weird. You know, I'm in quarantine, you know, I'm in jail in Florida. I'm like, oh, this is great. We're going to go to flight. Oh, God, I'm going to vomit 26 times next Tuesday. I mean, it's this weird life. It's this weird life. Adam, can you see it? Mount Everest is in this picture. I'll give you 5 seconds. So you can see it right here. Quite often, pictures of Everest show the snow blowing off the peak, and if you look really carefully, you can see that this is the Kumba icefall approach. So Adam said he was at base camp, which must be in here somewhere. This is the famous Kumba icefall right here. Beautiful. I mean, it's just, we're so lucky to be on this beautiful place. This is Egypt. So you can see the Nile River Delta is that green-shaped V at the top, and you can see the Nile River snaking through the desert. The Red Sea, the Gulf of Aqaba, that's the Dead Sea up on the right there. You know, theoretically, we talk about how you can't see borders from space. There's actually a couple you can, and one of them's in this picture. So if you look very carefully, just above my hand here, you can see the border between Israel and Egypt. Right here, see this line in the desert? And that's because Israel is such a small country, they do a lot of irrigating. There are seeds, you know, being carried by the wind. There's probably a fence here, and the seeds hit the fence and fall to the ground. That's why it's so green on the Israeli side. Then on the Egypt side, this is desolate. Sinai Peninsula, there's no need to really do anything out there. So that's why you see this. But we talk a lot about water here in California. So this is a nighttime view of the same place. And you can see water is life, right? I mean, everybody's living near the water. You can see them living along the Nile River as it cuts through the desert. You can see the Nile River Delta near Alexandria. It's very lush. That's why you've got the V shape. The really bright light there is Cairo. There's about 14 million people living there, something like that. The pyramids are right here. You can see the Suez Canal here. You can look at Israel. So there's nothing in the desert, then boom. So Tel Aviv is probably right there. But look along the Red Sea. See, there's people living here. Look at all the people along the coast. Okay, so water is very popular to where you choose to live, right? So the Earth is beautiful, but occasionally you do see human influence. So I just showed you a picture where you could see the nightlights, and you fly over it, you're like, what is that? That's not normal. That's actually a racetrack where they test cars. It's called the Nando Ring. This is Southern California, San Luis Obispo County. On the left is a picture from 30 years ago. Shows the farmlands. On the right is the Topaz Solar Farm. If you Google that, you'll see pictures of that. So we do influence what the Earth looks like. And of course, this is a very famous one. Again, 30 years apart on the pictures. This is Dubai. This is this famous Palm Island where they basically built these islands to build housing. So we really do need to take care of the Earth. This is an audience that is already aware of this, but let me take you through several pictures that show before and after. So usually it's about 20 to 30 years apart between the picture on the left and the picture on the right. This is what happens when you're mining in the rainforest in South America. This is Guyana. Picture on the left, beautiful river flowing through this very lush rainforest, and then on the right is an open pit mine. I'm sure there's some things being tossed into the river there. Even more dramatic is this picture from the Andes Mountains on the left. Again, 1975. On the right is, I think it's a copper mine, but you can see all the different pits they have for their tailings and their waste and all the roads. It's a pretty amazing difference. This is Saudi Arabia. When we look for water, sometimes we dig into the ground. And you'll see this in Southern California near Death Valley also. But all these round things is where they went down and got water, brought it up to the surface, and then gigantic sprinkler system goes in a circle. So here they're trying to find land to support the growing population. This is Bolivia. Again, on the left, beautiful rainforest, got this river snaking through, and then look at, I mean, amazing, 28 years later, just mowed down the forest, it looks like here, for croplands. This is also in South America. I think it's Brazil. I think it's near Manaus. On the left, you can see this beautiful river. And there is some evidence of humans here. You can see these roads back 30 years ago, and then look the difference. They've obviously built a dam also to create this lake. The reason you have these white lines with little things sticking off is the government probably mowed down the rainforest and built a road. And then, the settlers came along and said, hey, I'm going to build my farm here. And then they mowed it off to the side. So that's why you've got these tentacles coming off the roads. This is probably one of the most famous ones. It's the Aral Sea in Russia. On the left, you can already see it's starting to die. This is clearly not a good color of water. It's probably pretty shallow already. But this is a really good example, if I understand correctly, and there's been some National Geographic print and video stories about this, of water management misuse, both the water coming in and the water going out, without concern for what was happening to the Aral Sea. And you can see it's almost completely gone now. And if you look at some of the video and land video and magazine articles, there's ships out in the middle of the desert. And the ship is just sitting there on the sand and there's no water anywhere nearby. And that's because the Aral Sea is gone. We contribute to some of this. We don't want to just say it's everybody else, because if you've ever vacationed in Cancun, you contributed to this situation. It's kind of a tough thing to think about. But on the left is the Cancun, 30 years ago, and on the right you can see it's this massive growth that's taken a lot of the rainforest away. And here's a little closer to home. Any guesses? American city? Close. Las Vegas, correct. On the left, 20, 30 years ago. Here's McCarran Airport right here. This is where all the big hotels are. The Hoover Dam's just off to the side. You can see a little bit of the lake there. So, in America, we're doing the same thing. So what I would suggest to you is that the island is spectacular. You all know that. There's great places to experience the island here in California. We have a lot of people on the island, a lot. California, I don't know how many million we have, 30 million, something like that? How many, 39? And we need to take care of it. This is a page that I showed a group of children that I was trying to talk to about the environment. Sorry if it's a little bit simple. Anyway, we need to limit the damage, conserve our natural resources, of course, and use sustainable resources. So this is the Topaz solar farm in Southern California. This is a windmill farm out in the North Sea, just north of where we came from in the Netherlands. That's Cancun again. And number 4, we need to be nice to other people. And I really, really, really mean that. And I hope you take that away, that, we really need to remember that it's a global community. And, every day when you read the sad stories of violence happening around you, just think, why? Just really why? And so I would encourage all of you to do your best to help move us away from that culture, whatever technique works for you and your family. When we explore space, we do it because it's in our genes. Just all humans, not just Americans, to explore. We advance our society by doing that. We build technology, of course, and America has been really benefited from the space program in terms of technology advancement. It creates jobs and industries and products. It's pretty amazing to think, for example, that you can take a little piece of plastic anywhere in the world, stick it into a wall, push a couple numbers, and money comes out of the wall. I mean, you know, we forget about how amazing some of these things are. And your money's not even behind that wall. Your money is in California. So it's pretty amazing. And of course, mobile phones, my gosh. You know, Peggy was at her birthday dinner in Houston, Texas, and I was flying over Egypt on the space station. And I wanted to call her, and we have a cell phone on the space station. So I called her up, and she's sitting at the table, and I forgot the name of the restaurant, with her girlfriend celebrating. Oh, it's Steve, he's over Egypt, you know, just on this little cell phone, and it's amazing. Absolutely amazing. So, and there's so many other examples. But anyway, the space program does promote world peace. Think about it. We still work with the Russians despite some of the things that we don't necessarily agree with over the last 10 years. Georgia, you know, Syria, things like that. So my proposal to you is that the space program also promotes world peace. And I'd like to show you a picture that proves it. So I was on my 4th flight. I'm a Stanford person, so is Peggy. I was on my 4th flight, and God bless Rex Walheim was on his first flight. He's from Cal, grad, and you know, very nervous, you know, but we took care of each other. I said, bring a pennant with you, because after one of our spacewalks, we'll take a picture. And to this day, though, I can still rib him because you notice the color of the spacesuits is red and white. So I said, I still got you. But anyway, space is a place where world peace is promoted. So Adam, questions and answers. So let me just give you the agenda. So let me take questions for about 10 minutes because there is one other thing to tell you about. Peggy, could you go check out the setup? And I'll be here afterwards for a long time, as long as they'll let us stay here. Yes, ma'am.
Do you know about Edmund's project, the B6
Yes.
Foundation
Yes.
for Detection?
Yes.
And are you involved in that at all?
Not currently because I'm doing my job at NASA. But so she asked about another California astronaut, Ed Liu, who has a foundation to try and protect us from things hitting the Earth. As you know, there's been a couple meteorites that have hit the Earth in the last couple of years. And there's this theory that a really big one killed the dinosaurs many years ago. So his foundation is trying to make sure we have some type of planetary defense. And NASA, in fact, has a mission to go retrieve an asteroid someday as part of that process. Yes, ma'am. Oh, did you have a follow-up?
I have one more question. Do you know about there is the world's first public space training academy coming to
I don't know about, she asked about a public space training facility at Moffett. There actually are a couple in the world already where you can go.
It's going to be Moffett Field 48 years.
Fantastic. I didn't know that. Thank you for telling me that. And yeah, there's so many things I could have talked about. So tell me, give me some more. Yes, ma'am.
Totally awesome. I so appreciate you bringing this to us. And with all due respect, can you tell us how much fossil fuel is being used to
Yes.
things into space?
Absolutely. Yeah. So with any advancement, there's a cost. And so I'm asked all the time, what about the pollution that the rocket causes when it takes off? And how do you balance that? For me, it's a small investment for a big return. If we could spend hours here telling you about the satellites and how they've helped us improve understanding the world and helped us save lives with early hurricane warnings and things like that. I don't know the exact amount of pollution that comes out of the space shuttle when it launches, but I think it's worth it. That's my personal opinion. Small investment, big return. And I ask myself that every time when I take an airplane. Gosh, what's the balance here? So it's tough. So, yes, sir.
We're about 20 years from Mars.
Yes.
It took an enormous effort.
Did you see the next slide? Oh, okay, good. Okay, go ahead.
It took enormous focus.
Yes.
Not just by
Yes.
our country, but
Yes.
also the Soviet Union
Yes.
to get to the moon.
Yes.
How do we maintain the focus so
Great.
that we actually fulfill this mission?
Thank you so much. So he asked about, back in the day of Apollo, we got to the moon really quickly. John F. Kennedy said, let's go within 10 years, and we made it. And only 66 years passed between the Lindbergh's flight at Kitty Hawk and the time Neil Armstrong walked on the moon. 66 years. So the point there is that when you have a focus and a drive, and at the time it was beating the Russians, we can rally our country and do amazing things. And that's still true. But my theory is that we have so many competing interests now, and there's so much noise out there, it's hard to rally everybody around one common cause. We could get to the moon a lot faster than 20 years from now. if we had the right amount of money. I'm not whining, I'm just telling you that that's a fact, right? One interesting thought, if I could diverge a little bit, is wouldn't it have been interesting in 1945 if a government car was driving through Ohio and it went up to a farm in Ohio, went up, knocked on the door, and the lady answered the door, and the man said, "Good morning, Mrs. Armstrong. I'm here to tell you that that little boy playing marbles out there in the dirt 20 years from now is going to be the first human being to step on another celestial body." I mean, isn't that weird to think about? I personally think that situation exists today. The first person to walk on Mars is probably alive already. 5 years old, 10 years old, okay? It's an interesting thought. Have I broken the 30 mark? Have you learned at least 30 new things? I'm going to keep track someday. Okay, so let me tell you what's going on here. I'm Adam. So I have arranged for a pretty cool thing to happen. I have arranged for NASA to fly the space station over this building in 9 minutes. Okay, so I did my part. Okay, Mother Nature has to make sure the skies are clear. And it was pretty clear, but even a small layer of clouds can ruin it. What do you think? No, Peggy went out the way. Okay, the other problem is because of all the geometry, it's only 24 degrees above the horizon to the north. And because of this venue we're in a box, right? We go out in that courtyard, there's a building right there. So I don't even know if the space station's above that building. But I would suggest we go out there. We got 8 minutes. It always travels from west to east because of the way we launched. Remember I was showing there? So if we go out there, north is probably over there. Is that about right? I don't know if anyone can check on their compass. So it should be coming this way. I think we should go out there in a couple minutes. But it is 24 degrees above the horizon. It's called azimuth, which isn't very high. Tomorrow night, it's really good. Tomorrow night at 9:36, it's much brighter, and it's about 60 degrees. So tomorrow night, I suggest you go outside. Let's take a couple more questions. Yeah, we got a couple more. Yes?
I just want to point out that you can sign up for something called Spot the Station.
Yeah.
Send you an email whenever.
Thank you.
Whenever the space station is going to be above a certain height, tells you where it is, from to, how high it's going to be, how long it is.
Yeah, NASA.gov has another.
What's
Yes.
the risk of space junk or rock or something?
Yeah.
hitting the station?
Yeah, so the United States is the only country in the world that tracks space debris, and you've probably read occasionally over the last 10 years that it's gotten a lot worse. It is. We think there's been at least 1 or 2 satellites that all of a sudden stopped communicating with us that were hit by some of this debris. So the risk is getting worse. The world's space organizations did meet like 30 years ago to agree to design spacecraft such that they don't explode when they're done, and that the space agency has a plan to put it back in the ocean so it just doesn't go around the Earth forever and explode. So I can't quantify for you the danger, but it's definitely been growing. When I first got up to the Hubble Space Telescope, so hopefully this is not item number 40 that you're about to hear that's new. When I put my face right up to it, I'm climbing up and I'm looking at the skin from this far away. Totally pitted with space debris impacts. Not, 5%, but like 70, 80%. And after every shuttle flight, we replaced the front windows because they would get hit by things. And
Dust, basically, right?
pardon me?
Dust, basically, right?
Yeah, space particles, satellite parts, cosmic dust. Yeah. Next. Yes.
What was the duration of your longest flight, and what was your recovery process like after your return?
So the shuttle flights were about 2 weeks in length. I think the longest was 16 days. Mine were 12. The recovery process is some people just, they just walk right off the shuttle. They're feeling good. Other usually tall, thin people, a little bit takes to get your sea legs back. But Scott Kelly, I don't know if you saw him. He came back from a year, stood up. They were holding him, but he was doing okay. On the shuttle flights, we weren't allowed to fly airplanes for 2 weeks. We weren't allowed to drive for 5 days, just to not endanger the public, because we were just getting our bearings back. Yes, Rosalie.
For being accepted to actually going to space, how long was your training? I mean, from getting
Yeah.
up there, you're in.
Yeah. So the amount of time that you spend training from when you show up until you fly varies widely depending on a lot of things that aren't under your control. Was there just an accident? What was a class just selected? So we've had people wait 17 years. We've had some people never fly. For me, it was just over 2 years. So very lucky, good timing, yes.
So I'm just wondering if we have any programs or plans to clean up some of the not working space
Correct.
stuff, to clean up space junk, all that stuff.
There are people who are thinking how to do that, but there's no plan in place right now, except to try and prevent spacecraft from exploding. So let me just finish by saying I'm going to be here for as long as you want. I'll be out there. I personally am going to go into the courtyard, and I'm going to look that way. And if we can see it, you won't have any question. You know, if like an airplane flies over, you go, is that it? You'll know. It usually covers the sky in about 2 minutes. Very bright. Tomorrow night, 9:36. Again, I'm your servant. I hope I've educated you on enough on NASA to at least plant the seed that it's a small investment for a big return. And our one goal, and I forgot to read it on the chart, our one goal that I hope you always remember is that NASA's main purpose is to make people's lives better. That's our main goal. And I just noticed that we give out these bookmarks to children, and sure enough, the slogan on the front is ISS, off the Earth, for the Earth. So we're going into space to make people's lives better, either through direct discoveries or these spin-offs. And on the back, it's another slogan, we're working off the Earth, for the Earth. And you know, on behalf of myself, as Peggy and I as parents, with future generations to follow, thank you for taking care of the Earth. You guys are out in front, and I'm very grateful as a parent. So let's go outside. Let's go outside.